This is a very detailed tutorial on how to request the temperature and humidity data using Bluetooth and Arduino IOT. In this project, we will be making a feedback system. We will be sending a command to the Arduino wirelessly using Bluetooth, and then the Arduino will replay back with the temperature and humidity values. This technique is best as it never keep the microcontroller busy and sending messages again and again. Arduino will send message only if it receives a message from the owner. So let's get started. Let's start with the Bluetooth settings. So the Bluetooth module that you can see on the screen is actually Hc-05. Well, it doesn't matter whether you are using Hc-06 or Hc-05, the basic function of both the modules is same. There is only a little bit difference in the AD commands, which I will show you once we will doing the Bluetooth settings. So as you can see on the screen, the upper pin is the state, RxD, TXT, ground, and the VCC, and the last one is the wake up pin. So in the first part we will cover, we will be using the RxD, TXT, ground, VCC, and the wake up pin. So the wake up pin will be used for entering the Bluetooth module into the AD command, so which I will tell you when we will be doing the interfacing with the Arduino program. I will tell you how you can actually change the name of the Bluetooth module and how you can change the pairing code of the Bluetooth module. You can also use a default pin code, but in order to increase the security so that nobody else can connect with your Bluetooth module, so for that purpose I will tell you how you can change the pairing code of this particular module. So once we are done with the name setting and the pairing code, then we will use the cell phone to check whether the name is changed or not. So for that you will be needing an Android cell phone. First part, we need a cell phone and then a Bluetooth module and then Arduino IOT and a cable. So before you start the connections, first connect the Arduino and open a basic sketch which consists of only the white setup and white loop functions, and upload this. Now click the upload, and now as you can see here, now this sketch is uploaded, and now let's start the connections. Connect the VCC with a 5 and this one with the ground. The orange is the RxD pin, so connect this with the Rx pin, and the TX with the TX. And this is one extra wire which is connected with the 5 volt. As I told you that when we will be turning on the Bluetooth module, at that time we will connect this 5 volt with the wake up pin. So when we start the Arduino, it will enter into the AT command mode. So first, I'm not connecting this module. Let's check what happens if I just connect this. As you can see, the Bluetooth module is blinking fast and it's not in the AT command mode. So before you on the Arduino, at first you will have to connect the 5 volt wire with the wake up pin. So just hold it like this, and now just hold it for a second and then remove. Now as you can see, it's blinking slow, so it means that now it's ready, it's in the AT commands mode. Now let's open the serial monitor. So now let's check whether AT commands work or not. So write AT, yeah, it's working, AT, as you can see. Okay, now if you're using Hc-06, then you will have to enter the AT plus pin 1, 2, 3, 4. This is the format. So you will just write AT plus pin and then the pin code which you want to set. Like for example, it can be any 4-digit number. and device name can be set through this command AT plus name, and then directly write the name that you wanna write. But as I'm using Hc-05, so we will be using these commands. Now before you start the AT commands, you will have to do some settings. As you can see, the baud rate, which I have selected over here, 38400, and also select the NL and CR, which you have already selected. Now to find the pin code, enter AT plus PSWD. So just write this AT plus PSWD. Now the current pin code is 1234, and if I want to change the number, so how will do that? AT plus PSWD is equal to any number, so like AT plus PSWD is equal to, and this time I want to keep it 4321. It's the reverse one, and you can see that's okay. And now let's check AT plus PSWD, and now you can see it's changed to 4321. And now let's change the name. For changing the name, this is the command. So just write AT plus name equal to electronic clinic, and okay. So now let's connect this with cell phone. Close this, and okay, now restart it, reset the microcontroller, disconnect the Bluetooth module by removing the 5-volt wire, and now connect. So now it's blinking fast, it's not in the AT command mode. Now here's a cell phone, and open the Bluetooth, and let's search for this Bluetooth device. So now as you can see, its name is changed to electronic clinic, and now I just click on this, and now it's asking for the pairing code. Enter the pairing code, which is 4321, and click OK. So my friends, this is how we can set the name and the pairing codes. Let's start with the datasheet of the DHT11 temperature and humidity module. This is the temperature sensor that we are going to use today in this episode. This datasheet consists of all the information that you want to know about the DHT11. For example, its product overview, and number 2, the applications, which clearly explains that where you can use this particular sensor, the features, the dimensions, and the product parameters, which is the most important part, and you should give it a read, like the relative humidity, the resolution, the temperature, the electrical characteristics, which tells you that how much power you can give. The power supply is 3.5 to 5.5 volt DC. As in Arduino, we already have the 5 volts, so we can power this up using the Arduino power supply. And the pin description. As we know that the DHT11 has 4 pins, so the leftmost pin, which is the pin number 1, can be connected with 5 volts of the Arduino, and the pin number 2 is the data pin, and pin number 3 is not connected, and the pin number 4 is the ground one. So my friends, this is the typical circuit. Over here you can see that the pin number 1 is connected with VCC, which is 5 volts, and pin number 2, which is a data pin, is connected with P3.0, but it's also connected with a resistor, and on the other end of the resistor a 5 volt supply is connected, and pin number 3 is not connected, and pin number 4 is ground. So it means that while using DHT11 we will also be connecting a resistor. So if you you read all these information, you will clearly understand that why we are adding a resistor over here. Due to the tutorial limitations, we can't go into all the details. You should give it a read and you will understand that why we are using a resistor over here. So my friends, this is the basic circuit diagram which shows that how the DHT11 will be connected with the Arduino. As you know that the DHT11 has 4 pins, 1, 2, 3, 4, and the pin number 1 is connected with plus 5 volts. This 5 volt will be providing from the Arduino. And the pin number 2 will be connected with pin 12 of the Arduino, and as you can see the pin number 12 is also connected with a 10k resistor, and the other side is connected with 5 volts. The pin number 3 will not be connected, and the pin number 4 is connected with ground. So that's all for the circuit diagram. Now we will make this circuit on a Vero board. We will do the soldering, then after that we will interface the circuit, and then we'll start the programming. We will solder the DHT11 sensor onto the Vero board, as you can see. So first of all, we will solder one leg of the DHT11 sensor onto the Vero board so that we can align this. And then after that, we will use the alligator clips to solder the remaining pins. While soldering, make sure that you don't apply too much heat because this can damage the DHT11 sensor. So now as you can see, there is no short circuit, and we are doing all this soldering as per the circuit diagram which you can see. So now it's time to solder the 10k resistor as per the schematic. So now the 10k resistor is soldered. Now it's time to solder the wires. This is the 5 volt wire which is connected with pin number 1 and one side of the 10k resistor, and now this is the ground wire on pin number 4 and the green wire is on pin number 2. So all the wires are soldered. So my friends, this is the complete project circuit diagram. We have already discussed DHT11 in very detail, and of that we also did the soldering, and it will be connected with pin 12 of the Arduino. Now on the right side you can see we have a Bluetooth module. So well my friends, it doesn't matter whether you have Hc-05 or Hc-06, the programming is 100% same. You can see that the RxD pin is connected with pin 8 of the Arduino, and the TXT pin of the Bluetooth module is connected with pin 7 of the Arduino. And make sure that you connect the ground pin of the Bluetooth module with the ground of the Arduino, and same for this one, that you have to connect a ground wire from this module with the ground of the Arduino. Now as you know my friends, that the Arduino has already a built-in serial port which is on pin number 0 and pin number 1, and the question is that why I'm using pin number 7 and 8 as a serial port, why I'm not using pin number 0 and 1. No, my friends, the answer is that I want to use the Arduino IOT default serial port for the debugging purposes. So it means that if I'm using that port for the debugging purposes, it means that I will need another serial port with which I can connect this Bluetooth module, as it will be doing serial communication with the Arduino IOT. So for that reason, I will use pin number 7 and pin number 8 of the Arduino IOT. I will be using software serial library. If you want to learn in detail how to use software serial to make multiple ports, you can watch my tutorial. And so that's it. Pin number 7 and 8 will be used for the Bluetooth module, and pin number 12 will be used for the DHT11 sensor. And one more thing my friends, I want to tell you that the DHT11 can read only positive temperature. If you want to read the negative temperature, then you can use the DHT22, which can also read the negative temperature. The basic use of both the sensors is exactly same. So now let's start the interfacing. So friends, as you can see, the DHT11 sensor is connected, and you can see over here the wire is connected with pin 12 of the Arduino, and its 5 volt wire is connected with pin 6 of the Arduino. So I will power up this using pin 6 of the Arduino. and similar this ground wire is connected with the ground of the Arduino, and on this side you can see the Bluetooth module is also connected. These are the wires which are connected with pin 7 and 8 of the Arduino, and its ground wire is connected with the ground of the Arduino. So my friends, this is the code. Let's start with the command, which is the v is equal to feedback request. Actually we will be sending the character v from our Android cell phone. When the controller will receive the v, it will send us the temperature and the humidity values. So it's like a feedback system, so it will send us the data only when we will request for the data. Okay, so let's start with the Hc-include software serial.h. .h means that it's a header file, and Hc-include means that it's a preprocessed directive, and software serial.h is, I told you, my friends, that we'll be using two serial ports. One serial port for debugging, which is the Arduino default serial port, and another one which we define on pin number 7 and 8. That one we'll be using for the Bluetooth module. So for making a serial port, we will be needing a library, and this is that library, software serial.h. so if you want to make multiple ports, you will need this library, so make sure that you add this, otherwise it won't work. Then Hc-include the DHT.h. so if you're using DHT11 or 22 or 21 sensor, then you have to include the DHT1.h header file. H defined DHT pin 12 as in the circuit diagram. I already explained that the DHT11 sensor will be connected with pin 12 of the Arduino. So if you are using DHT22 or DHT21, simply uncomment this line and comment this one, and you're good to go. And these are the information about how you connect the DHT11 or 22 or 21 with the Arduino, which I already explained in circuit designing. Then DHT pin and DHT type. This is actually a function, and it's taking two arguments as the input. The one is the DHT pin, which we already said, which is the pin 12, and then the DHT type, which is defined over here if you're using DHT11. So now character in character, so as I said that we will be sending a character from the Bluetooth module, so we will be storing that character in character. Software serial blue and 7 and 8. So as in circuit diagram, I already explained that the Bluetooth module will be connected to pin number 7 and 8. So 7 is the RX and 8 is the TX. Now string text for SMS, string humidity is equal to humidity, and string temperature, and so these are just a variables of a type string. So integer power B equals to 6. To power up the DHT11 sensor, DHT11 5-volt wire is connected with pin 6 of the Arduino. Well, if you want, you can also connect this wire with the 5-volt of the Arduino, but as I've already connected the Bluetooth module with 5-volt, and I was feeling so lazy that I just didn't connect that wire with the 5-volt. So what I did, I just took that wire and connect it with the pin number 6. So I will power up DHT11 using pin 6 of the Arduino. And my friends, as you know that every Mega and Arduino Uno program has at least two functions. The one is the void setup and the other one is a void loop. Void means that this function is not returning any value, and the empty parenthesis means that these functions are not taking any argument as the input. So serial.begin 9600. So as I said that I will be using the Arduino default serial port for debugging purposes, so for that I will have to first activate serial communication. That's why I have activated this using this function, and I'm using a baud rate of 9600. Blue.begin 9600. Now to activate the Bluetooth module, we will have to turn this on using this instruction, and the baud rate is 9600. And DHT begin, so pin mode power B output, and it's high, so the DHT11 sensor is now high. And now the void loop. If blue dot available equals 0, it means if we didn't receive any character from the Bluetooth from the Android cell phone, so just wait over here and do nothing. If blue dot available greater than 0, if we have received a data from the Android cell phone through Bluetooth, so what to do then? In character equals to blue dot read, serial dot print in character. So this line I'm using for the debugging purposes, that whether I have received or not. So I can, when I will be turning on this serial monitor, then I can see that whether the communication is working or not. So delay 20, just wait for 20 milliseconds. If in character equals V, so as in the beginning I told you that I will be using V for the feedback. So this is the command for the microcontroller. When it receives V, it will send me the desired data. And delay 10 milliseconds, serial.print in character, delay 2000 milliseconds, 2 seconds, and then integer h equals to DHT read humidity, and integer t is equal to the read temperature. So these will be having these two variables. The h and t will have the values of the humidity and the temperature respectively. And this is just for the if the DHT sensor fails. So it's just checking over here, and then over here we are making a message. So text for SMS equal to text for SMS plus humidity, and then we just add with it the humidity value, and then text for SMS equal to text for SMS plus the temperature, and text for SMS dot concatenate T, which holds temperature data, and then we add the C and blue dot print, and then we send this message to the Bluetooth module through it. And serial dot print line text for SMS delay 2000 milliseconds is equal to 2 seconds, and then after that we just clear the variable. So simple program. I will provide a link in the description, then you can download this code from my blogger page. So now let's power this up, and so now you can see the Bluetooth module is blinking fast. It means that it's not connected with cell phone. So let's connect this. First of all, let's open Bluetooth. I've already paired this. Open the software. Now click on the search for paired devices, and over here you can see electronic clinic and connect. Now you can see the LED is blinking at a slow rate, which means that now it's connected. And you can see over here I'm not receiving any data. Why? Because I didn't send any command. So let's send V. And you can see it replied with humidity 14% and temperature. So now let's clear. You can also clear this, and now look at this. Look at Arduino. So let me send again. And you can see over here. Let me send again. And I received it again. So you can clear, and now let's send again. So temperature is 31 and humidity is 38%. So my friends, that's it for now. I hope you liked today's episode. In the next tutorial I will show you how you can use a GSM module and Bluetooth module together to read the temperature and humidity values. For example, if you are in the Bluetooth module range, then you can simply use your Android cell phone to read the temperature. And if you are far away from your home and you are not in the range of Bluetooth module, then you can use a GSM module. So in the upcoming tutorial I will show you how you can use GSM and Bluetooth module together. So my friends, like my videos, share my videos with your friends. See you in next episode, and thanks for watching.